So the TensorFlow team with TF2 has solved a hard problem, which is to make it easy for you to easily express your ideas and debug them in TensorFlow. This is a big step, but there are additional challenges in order for you to obtain the best results for your research or your product designs. And I'd like to talk about how NVIDIA is solving 3 of these challenges. The first is simple acceleration. The second is scaling to large clusters. And finally, providing code for every level, every step of the deep learning workflow. One of the ingredients of the recent success of deep learning has been the use of GPUs for providing the necessary raw compute horsepower. This compute is like oxygen for new ideas and applications in the field of AI. So we designed and shipped Tensor Cores in our Volta and Turing GPUs in order to provide an order of magnitude more performance capability, compute capability than was previously available. And we built libraries such as cuDNN to ensure that all the important math functions inside of TF can run on top of Tensor Cores. And we update these regularly as new algorithms are invented. We worked with Google to provide a simple API so you can, from your TensorFlow script, easily activate these routines in these libraries and train with mixed precision on top of Tensor Cores and get speedups for your training with examples here, for instance, 2x to 3x faster, which helps you iterate faster on your research and also maybe within a fixed budget of time get better results. Once you have a trained model, we provide a simple API inside of TensorFlow to activate TensorRT so you can get drastically faster latency for serving your predictions, which lets you deploy perhaps more sophisticated models or pipelines than you would be able to otherwise. But optimizing the performance of a single GPU is not enough. And let me give you an example. So Google last year released a model called BERT. As Jeff Dean explained yesterday, this model blew away the accuracy on a variety of language tasks compared to any approach or model previous to it. But on a single GPU, it takes months to train. Even on a server with 8 GPUs, it takes more than a week. But if you can train with 32 servers or 256 GPUs, training can complete with TensorFlow in mere hours. However, training at these large scales introduces and poses several new challenges at every level of the system. If you don't properly co-design the hardware and software and precisely tune them, then as you add more compute, you will not get a commensurate increase in performance. And I think NVIDIA is actually ideally, uniquely suited to solve some of these challenges because we're building hardware from the level of the GPU to servers to supercomputers, and we're working on challenges at every level on hardware design, software design, system design, and at the boundaries of these. The culmination of a bunch of our work on this is the DGX SuperPod. And to give you, to put its capabilities sort of in visceral terms, a team at NVIDIA recently was able to, on the DGX SuperPod, as part of Project Megatron, train the largest language model ever, more than 8 billion parameters, 24 times larger than BERT. Another contribution that NVIDIA is making and what we're working on is providing reliable code that anyone from individuals to enterprises can build on top of. NVIDIA is doing the hard work of optimizing, documenting, qualifying, packaging, publishing, maintaining code for a variety of models and use cases for every step of the deep learning workflow from research to production. And we're curating this code and making it available to everyone, both at ngc.nvidia.com, but also other places where developers might frequent, such as GitHub and TF Hub, which you just heard about as well. So I hope that in this short time, I was able to convey some of the problems that NVIDIA is working on, the challenges we're working on, and how we're making available to the TensorFlow community, along with Google, simple APIs for acceleration, solving scaling challenges, putting out DGX SuperPods, building GDX superpods, and curating code that anyone can build on top of for the entire deep learning workflow. Thank you for your time. I hope you enjoy the rest of the conference.